Sometimes you can solve a problem using a proportion. That's an equation involving two rational expressions set equal to each other. A rational equation contains at least one rational expression. You can simplify solving a rational equation if you first clear the equation of its denominators. You can do this by multiplying the LCD, or least common denominator, of the rational expressions in the equation. First consider the rational equation x over x plus 1 plus x over x minus 1 equals 2 over x squared minus 1. Considering that the denominator on the far right is a difference of squares and can be factored as x minus 1 times x plus 1, we see that our least common denominator is x plus 1 times x minus 1. Multiplying each side of the equation by x minus 1 times x plus 1, the equation is completely cleared of denominators, and we end up with the equation 2x squared equals 2. Anytime you multiply each side of an equation by an algebraic expression, it is possible to introduce an extraneous solution. Recall that an extraneous solution is a solution of the derived equation, but not a solution of the original equation. You must check all solutions in the original equation to confirm that they are indeed solutions, and not extraneous solutions. Problem 1. Solving a rational equation. What are the solutions of the rational equation? Part A. X over x minus 3 plus x over x plus 3 equals 2 over x squared minus 9. Consider what you might think on the left and what you may write on the right as you work through this problem. First think. Factor the denominators to find the least common denominator. And write the equation with each expression in its factored form, x over x minus 3 plus x over x plus 3 equals 2 over the binomial x minus 3 times the binomial x plus 3. Next think. Multiply each side by the LCD to clear denominators. Our least common denominator is x minus 3 times x plus 3, and so we multiply each side of the equation by that LCD, x minus 3 times x plus 3, to clear the denominators. Next think. Now simplify and solve. And so we do. Our equation becomes x squared plus 3x plus x squared minus 3x equals 2, having cleared denominators. Combining like terms and simplifying, 2x squared equals 2, x squared equals 1, so x equals plus or minus 1. Next think. Check whether x equals 1 or x equals negative 1 is extraneous. Use the original equation when checking. So we check. First substituting 1 in place of x, 1 over 1 minus 3 plus 1 over 1 plus 3, does that equal 2 over 1 squared minus 9? Simplifying, that's negative 1/2 plus 1/4. Does that equal negative 1/4? Sure enough, it does. So 1 is a solution of the equation. Next, we'll check negative 1. Does negative 1 over negative 1 minus 3 plus negative 1 over negative 1 plus 3 equal 2 over negative 1 squared minus 9? Simplifying, that's 1/4 plus negative 1/2. Does that equal negative 1/4? Sure enough. So that solution checks out as well and is also not extraneous. So next think. Write the solutions and write the solutions are x equals 1 and x equals negative 1. Your turn, part A. What is the solution of the rational equation x minus 1 over x plus 2 equals x squared plus 2x minus 3 over x plus 2? Part B. What is the solution of the rational equation x over x plus 1 plus 3 over x plus 4 equals x plus 3 over x plus 4?